Okay, Assalamu alaikum and welcome to Module 2, Week 5. In this module, we will start talking about the microprocessor structure in details, and we will see how a microprocessor is built and what is the difference between different microprocessor architectures. So, in order to understand microprocessors, we need to go lower than high-level programming languages. So, usually, a high-level programming language such as C++ or C does not show the actual instructions that are used to program a microprocessor. So, in order to do that, we go to the lowest level, which is the assembly language programming. So, why we are using low-level assembly language? Communicating with the operating system is easier. Optimize critical areas of applications. It minimizes the size, maximizes the speed, avoid instructions of high-level languages, and we can access the actual hardware of the computer. So this is our main objective. So some definitions that we need to know. We have the assembly language, which is a machine-specific language with one-to-one correspondence with the machine language for the computer. We have the machine language itself, where the language a particular processor understands, and finally we have the assembler, which converts from assembly language into machine language. So basically assembly language is a language that we can convert easily into machine language. After converting to machine language, the processor will understand the language very easily. So for some example, consider that we want to add A plus B in a high-level programming language. If we want to add A plus B in a high-level programming language, we need to convert it into assembly language. The conversion will be move A into AX, add B to AX, and finally move AX to X. Okay, because we cannot add two variables. Okay, we cannot add two variables over here and then in assembly language. Yani in assembly language, we cannot say add A comma B. Okay, this is not acceptable because we don't know what is A comma B. Now A and B over in this high-level programming language basically represent the variables which are stored in the memory. So we can read from the memory, put in a register, then add a memory to register, and finally add AX to X. The machine language conversion will be A1 0002, 06 0004, A3 000. So this is basically what is done. So in English, display the sum of A times B plus C. Okay, so in C++, it is C out, A multiplied by B plus C, which is this one should be over here. Okay, in assembly language, move A to EAX, mul B, add C to EAX, call, write, interrupt. And in machine language, it is this code. So as you can see, it's quite simple and easy to use high-level programming language, quite simple and easy. But when it comes to assembly language, one-line program such as this cout code will be converted into at least 4 lines, and it will have 4 corresponding lines in machine language. Now data types, we have the 8-bit, byte is 8 bits, word is 16 bits, double word is 32, and quad word is 64. We have some unsigned integer values. Byte is, since it's from 0 to 8, sorry, it's 8-bit, it is from 0 to 2 to the power 8 minus 1. Word is the same, and quad word and double words are the same. Now, when we have a base 16, as we know, which is hexadecimal, it is from 0 to F, and a shorthand notation for convenience. Here, when we have hexa, we will write H after it. And when we have binary, we will write B after it. Okay? So if I say F6H means F6 hexa, 9D0A hexa, F6E7 hexa, 5B hexa. Okay, these are the value of the hexadecimal numbers. Of course, we all know how to convert from hexadecimal numbers to binary numbers. Conversion is straight forward. These are straightforward. We all know how to do the addition and subtraction in 2's complement. We studied this in fundamentals of computer systems, but we will go through some examples later on in class. The addition and subtraction in hexadecimal. We have the storage types and ranges. We have the unsigned integers, unsigned words, unsigned double words, and unsigned quad words. We have the signed values. Then we will go for the computer architecture. Now, when it comes to computer architecture, we have the processor contains ALU, control unit, and registers. We have then the outside memory, which is mainly the RAM. But what we are concerned in over here is these three parts inside the processor, because we are programming the microprocessor. So the CPU communicates with the main memory, secondary memory, input-output devices through the system bus. And we said that the system bus is composed of three different buses, which is the data bus, the address bus, and the control bus. Okay, so it comprises of these three buses. We talked also about the von Neumann architecture, and we said it has one memory for both data and instructions. The processor, again, it has these three main parts, and here we talk more about the buses: the data bus, the address bus, and the control bus. Then we will have an example talking about the data and address control over here and how it works. The arithmetic and logic unit in a computer basically it will do arithmetic operations and logical operations. The arithmetic operations are addition, subtraction, multiplication, and division, increment and decrement. When it comes to logical operations, we have the AND, OR, XOR, and NOT operations. So the arithmetic and logic unit is built out of adders, subtractors, shifters, multipliers, decoders, multiplexers, and comparators. When we want to implement an ALU, it is capable of computing one of four of the other functions, which is the AND, OR, NOT, and SUM. Basically, this is the simple ALU implementation using a circuit. And you can see here, this is for 1 bit. This is the logical unit, and this is the arithmetic. This is the full adder circuit, and this is the decoder for the selection. Now, this is the explaining of the implementation, and this is the 1-bit adders, which we are going to talk about, and we explain this. We will explain this in full details. Then we are going to talk about the data path, and the data path is basically the registers plus the ALU. Now, the data path consists of the components that supply instructions and data, and that perform the operations called in the instructions. So we have the memory, the register file, the program counter, the instruction register, and the buses. So we are going to talk about these in full details. What is a program counter, what is an instruction register, and what is the register file. So the data path, the control unit is responsible for generating the required signals to activate the data path components at the appropriate time. The components used depend on the type of the instructions that is being executed. The separate adder can be used to increment the program counter to allow sequential access instructions. So basically, this is what we are going to discuss. A brief introduction for you. We are going to discuss all of this in details. Quite straightforward. It's just an introduction for microprocessors. Hope that you are all safe, and see you all soon.